Hello everyone. In today's session, I will be discussing answers to previous year's questions asked on topic ozonolysis. You can refer my previous video on tricks for ozonolysis and reverse of ozonolysis. You can check the description box for the links for the previous videos, which I have uploaded on my channel and Insta page. So let's get started. So the first question, in the following sequence of reactions, the alkene affords the compound B. The reaction is but2-ene. When undergoes ozonolysis, it gives A, and then further reaction with zinc and water, it gives B. So we need to find out what is the final product, that is B. Now, first of all, we will quickly carry out the ozonolysis using the tricks which I have shared. Now, this is O3. Simply you need to put oxygen on these two carbon and the third oxygen will be bonded over here. So A will be CH3, CH, bond CH, bond oxygen. This will be bonded and then this is the oxygen. This is the CH3 group. Clear? Now further cleavage will take place in this way. This is the cleavage and then the final product getting is CH3 CHO plus CH3 CHO. So the correct answer is C, that is we are getting 2 moles of acetaldehyde. Let us proceed with the next question. The next question, the alkene which on ozonolysis yields acetone is given the alkene which on ozonolysis it gives the acetone. So in the options we have been given the reactant part. So first we will write down the acetone structure. This is the structure for acetone, CH3, C double bond O, CH3. Okay. So now I'll just quickly rearrange this thing. I can also write down acetone in this form. So CH3, CH3, double bond O, and then 2 moles of acetone we need to write down. This thing will be C double bond O, CH3, and then CH3. I've simply rearranged the structure. And then if you have followed my previous video, you must know the trick that we need to remove both the oxygen and then the carbon and carbon will be bonded by double bond. Okay. So the reactant will be CH3, C, CH3, double bond C, CH3 and CH3. So this is the reactant part which on ozonolysis with O3 and then further reaction with water and zinc gives me 2 moles of acetone. So the correct answer is C. This is the correct answer. As you can see, C, CH3, 2 CH3 we have on this carbon and then 2 CH3 on the second carbon bonded with double bond. Clear? The next one is the third question. 1 mole of propanone and 1 mole of formaldehyde are the product of ozonolysis of 1 mole of an alkene. The alkene may be, we have been given propanone and formaldehyde. So I will write down the structure for propanone. So this is the structure for propanone, CH3, CH3. Propanone is nothing but acetone, remember, plus formaldehyde, which is also called as methanol. So this oxygen, I will put it over here. This thing will be hydrogen and hydrogen. So finally, you know the trick. Oxygen and oxygen will be removed. And then in the reactant part, I will get CH3, C, CH3, double bond, CH2. The name of the structure is 2-methyl propene. It is 2-methyl propene. So quickly tell me, students, what will be the answer? Option yes. Option A is the correct answer. Now the fourth question. Olefin which on ozonolysis gives CH3, CH2, CHO. This is the structure for propanol. The name of this compound is propanol or propionaldehyde. And then the second structure is ethanol or acetaldehyde. Now again, we need to carry out the reverse of ozonolysis. So again, I will draw the structure of propanol and ethanol. So the structure will be, this is propanol, C down as C, double bond O, H, CH2, CH3. This is the structure for propanol, and for ethanol, I can write it down as CH3CHO, which can also be written as C double bond O, H, and then on the left hand side CH3. So these are the two products which we are getting after ozonolysis. So before ozonolysis, which alkene is present, we need to find out. So the trick is, you will simply remove this oxygen, and then the reactant will be CH3CH double bond CH, CH2 CH3. The name of the structure is 1, 2, 3, 4, 5. 5 carbon we have. So the word root will be pent, and then 2-ene. So the correct answer is pent-2-ene can also be called as 2-pentene. So the correct answer is D. Clear? D. The last question. Which one of the following gives on ozonolysis both aldehydes and ketones? Okay. Now the trick is, always remember, if carbon containing double bond, it has a hydrogen present, then it will be giving the product as a aldehyde. If both the carbon does not have any hydrogen, it will be giving ketone. If one of the carbon has containing hydrogen and the second carbon not containing any hydrogen, then it will give the mixtures of aldehyde and ketone. Okay. So the question asked is, which one of the following gives on ozonolysis both aldehyde and ketone? So the answer will be, so quickly look into the options. You can, and I can see that the carbon double bond carbon, one of the carbon it contains hydrogen, the second it does not contain any hydrogen. So this can be our correct answer. Okay, it can give ketone and aldehyde. Let us have a look on the other options. Now for the second option, that is B option, both of these carbon does not contain any hydrogen. So it will be giving us 2 ketones. This third option, again these 2 carbon does not contain any hydrogen. Again it will be giving us both the ketonic group. The last one, it contains a hydrogen. It will be giving us both the aldehydic group. So our correct option is A, because it contains what? Because it can give aldehyde and ketone. So this is how you are going to use the trick to solve the questions for any competitive exam in less time. So keep watching my channel and subscribe my channel for more interesting videos and to solve the mystery of chemistry in easier way. Thank you.